Please give a warm welcome to Sergey Dolganov. He's working at Evil Martians and he's currently working remotely and on a European trip. And thanks for being here, Sergey.
Thank you. So, hello everyone, my name is Dolganov Sergey, and today I'm going to talk about how we build resilient distributed applications using mostly two things, the contracts approach and implementing of sagas. A couple words about myself. I came to you from St. Petersburg, where I live with my dog and the drum kit, and most of the spare time I spend with them. And today I'm here because I'm working in a company called, whoa, sorry, this is not right. Okay, so I'm working in a company called Evil Martians, and at Evil Martians we help startups to grow their business at warp speed by using, creating, and contributing to different open source tools. And the project that I'm working on called eBay Mac, or eBay for Business, where we help eBay sellers from 30 countries, some are from the Eastern Europe and Russia, and some countries from Asia, to sell millions of products. And under the hood, the interesting point is that it is this fully distributed system because almost any action of our user ends up with changes in the external system which we have access only through HTTP API. And we found what is the best way, the responsible way of building such complex application by using contracts. And when I'm talking about contracts, I don't really mean some library or gem. I'm just talking about the contracts approach. And when you thinking of contracts approach, you have to keep in mind three types of things: preconditions, postconditions, and invariants. So let me show how it is applied. So you could imagine that any functional block in your system could be controlled. And by that I mean that you could apply some rules for the input, some rules for the output from this functional block, and some rules for the state that is changed during this functional block processing. And if any of those rules are broken, you actually halt the execution of your functional block because you actually don't understand how to process the execution later. And this is actually contracts approach in general. And finally, we built an application that fully complied with contracts approach, but it was not built that way from scratch. So let me tell you the story of evolution of our application through those steps. So first of all, we needed an input-output control, then state control, and finally, how we came up to homogeneous design of this control logic. The story starts several years ago when our sellers came to us and said, you know, we had many orders sent through DHL, and it would be great if we could automatically register it in DHL through a button click in the eBay Mac. We said, no problem, let's take a look. Oh, it's pretty simple. We have an API client, we have business domain, we have external system, let's communicate and just start working. We deployed it and understood that actually in real world, DHL is the real system that has its own peculiarities and behave in different way which we could not predict, and actually it's not written in documentation. And at this point we understood we've already deployed it, we have an application in production, and the only way to get knowledge how to write it properly is to debug it in production. So the first chapter is called standalone policy. And it's called that way because to work properly, we introduced a lot of validations between the business domain and the API client. And actually, each validation is just a policy object. But also, to gather this knowledge, we introduced a concept that we called contract. And actually, I was inspired by the Netflix idea of chaos engineering when they said, you know, debugging in production is not that bad. So I started to think in what we could do to actually gather the knowledge. And we decided to have a tagging system for each response and request between our systems. And each tag is just a marker what kind of information we have about this communication session. And if we were not able to understand how to process this request and response, we mark it with unexpected behavior. So pretty simple class, and for each request that we have, for example, this is the tariff request for the DHL. But then, when we get rid from the unexpected behavior tags, we needed to put the logic somewhere in the system. So we created different policy objects. So we put it at first in the validations for the parcel that we plan to send, then put them in some logic about what actually DHL expects from us. Then we transferred it to the request. So let me show you what is the policy object. Policy object is just some tool that we introduce in our company. It's called Trump policy, and it's just the simple abstraction over errors, actually. So it works totally the same way as active record validations, but don't have any dependencies except dry initializer. And so you just listed the what are the options or parameters that you expect, and then the methods that you plan to run as a validation. And the validation is just a method that could add something to errors list. If errors list empty, policy is valid. So after we pass several policies, we have here a call to class called tariff mapper. So tariff mapper is nothing more than just a dry initializer class. So it has some input, and as the output is generate some hash that could be simply transferred to the XML or JSON or anything you want. But you can see here that there is some default logic, because sometimes when we transfer our business domain models to DHL, we have to change a little the values and stuff like that, so that DHL will accept it. And this is final solution that actually worked pretty well, and it worked like that till the last period. And we understood that it's quite complex, because actually we could see here a problem. The problem here is that we're missing an abstraction, because all this logic lives in some service object. Service object means that we don't know actually what it is. We just put the code in the class and said, service object, that's right. But we postponed the problem, and actually we've got what we want. We had a DHL integration, and it worked. So under the hood, it uses dry initializer, Trump policy, and the thing that I called contract is actually a gem that was created during the DHL integration and called blood contracts. Then, one day, our sellers came to us and said, you know, in Russia, things are going in other way. Actually, they use Russian Post to send their parcels, and they actually send around 1,000 parcels per one seller. So we had actually millions of parcels, and they don't want to register them by hand. You know, thousands of times you need to click the button. So they said maybe you could automatically register parcels in the Russian Post. So we started to thinking, what is the difference? The difference is that we actually have to run several operations over external system in one transaction, because if we are failed, we don't want to Russian Post have some information that somehow messes the communication between systems. And which is why the second chapter called sagas. Sagas is just fancy name for the business transaction or the distributed transaction. And in the case when you don't have access to the source code of the other services you use, there is an approach called orchestration. And it says that every time you communicate to the external system, you should wrap mutation in a pattern called command. Command just means that you have a rollback method. So you could think of Rails migration with up and down methods. Then you should somehow change those commands and run them. And if everything is OK, you've got it. But otherwise, you should run them in the reversed order and run the rollback command. For us, it was undo method. And under the hood, it was like that. So the orchestrator class we called pipeline. And on the left side, we receive a parcel. On the right side, as the output, we receive also a parcel, but with the asterisk, that means that it could be either parcel in the initial state or the parcel that was successfully registered, paid, and stuff like that. And on the way, we are running different validates, get transportation cost action, and stuff like that. Inside is just the communication between, single communication between systems. And if something fails, we just roll back it. So simple. Why we don't have a library for that? I wrote it. You guessed, yeah, it's not working. So what happens in real world? And actually, I started thinking about, first of all, we've got some runtime orchestrator error, and our chain fails to execute. Not a big deal, but what happens if actually your application shuts down in the middle? We run our application over Kubernetes, so every pod could just be restarted at any point of execution. And yeah, it happened several times, you know. I don't like remembering it, but yeah. And last thing, I said that we had thousands of processes that we run in parallel, and that means that it's the background execution, and we could not predict the order. So sometimes we could just start the pipeline with the same subject simultaneously, but we communicate to the external system, so state could just mess up. So we started to think, and here is the solution that we came to. So in the Ruby code, you just write a pipeline. With this is a class with a method chain, and chain is just exists to list what operations you plan to run in one transaction. After you finished your chain, you just initialize it with the subject and call it. And you could see interesting moment here that we don't have any if, else, or any other conditions. We just return the status payload, because as a result, we always get the status object, whether it's failure or success. So in the success case, the payload will return us the successfully registered parcel. In the error case, we just see here the errors that we've got. But what's interesting happens under the hood. So you could see here that there are events. Yeah, the only working solution that we found uses event sourcing. So who is here familiar with event sourcing? Okay, so let me clarify that is a pretty simple thing, at least for our case. Event is just, you could think of two tables. You have table for events and for event completions. So table for events is just a mutable table. That means that if some row created here, it never changes. And it could contain any kind of information that you want to store. The second table, event completions, are just markers about whether a particular event was processed or not. And that's pretty much it. And actually, we didn't have event sourcing before, so we introduced it, and also we plan to open source it soon. So you could have event sourcing in your Rails application just like this. But anyway, so for our case, what do we need? So let's start from the start. So we have a subject that we put into the pipeline, and at the moment when we call the pipeline, we lock the pipeline by the subject. So we don't have problem about parallel execution of the same subject by same pipeline. Then each action contains one single important thing. Before any communication to external system, we create an event that is called action attempt. So we don't know what is the result, but we exactly know that we will try to run mutation in external system. So we will use it as a breadcrumb later. Then we run the chain, and finally, when the chain execution finish, we create another event that, let's call it done, and where we put whether the communication is successful or not. And then we handle those events. So only at that point. So done event processor behaves differently in successful and in failure case. So in success case, it just reads the action attempt events and processes them one by one. You can see here that we use operation called applied. For most of the cases, it could just be omitted, but for our case, for example, when we communicate to the eBay, we don't know what is the final state. So that means that when we apply the mutation, eBay just says, OK. And we don't know what is the state and how actually it changed. So at the end of the pipeline, we should make sure that actually external state and the state of our system are synchronized. This is why we call the applied method. Then, if this chain or this action attempt event processing was successful, we are able to unlock the subject and return the result and continue the execution. But what happens if some action fails? The same thing, we just generate done event, but with the failure status. And this process in a bit different way. So we just read the action attempt events, reverse them, and run the undo method. Exactly as it was told in the documentation. But what happens if we were unable to undo it? So sometimes it happens, and I call this situation manual recovery error, and that means that we were unable to automatically return the state to the initial one, and that means that we have to communicate to the developer because he have to make sure that everything working correctly. This is why everybody says we don't have distributed transactions. It's not working like in database, and never would. So an interesting thing here is you can see that subject is, so the pipeline is still locked by the subject. That means that we will not ever continue, we will not ever able to run this pipeline over the subject because it's still locked. But this way we are totally make sure that the state will not mess up again. And this solution gonna be open source, so I will share the actual code that we use in a gist file. It is not open source yet, and I'll tell you why a bit later. But under the hood, it's pretty simple. It has no dependencies. Only 6 abstractions are used, and 2 of them are interfaces. If you are interested in more details, you could check out my previous talk in Belarus about it in more details. And interesting point here. I didn't tell you what happens if actually our application was restarted, for example, or stuff like that. By the using event sourcing, we are able to actually continue execution from the moment where we stopped. So if let me return. So if, for example, the chain failed or application was restarted in the middle of the chain, after a while, we have a regular job that will generate a done event with status failure, and we'll try to run the rollback. So it will be handled automatically. Otherwise, if we were restarted during the cleaning process, we also know which action we processed, which are not. So again, lots of things are able to process automatically. So one day, our sellers came to us and then said, you know, in many European regions, UPS is much more popular than DHL, but they look pretty the same. We think that maybe it's easy to introduce it. We started to thinking of it. We exactly got the idea that they're pretty similar on the high level, but we understood that we couldn't actually reuse any line of code from the DHL because we missed serious and important abstraction here. So we started to thinking about how actually organize all these validations to get rid of these service objects. And I started a discussion in our company, and some guys who got a lot of knowledge said, you know, actually you have to write it in Haskell. And because in functional languages, the validation is the best thing that you could actually find. So I started to learn Haskell. Yeah, it took me a while. Yeah, and after that, I fell in love with functional programming. But I still love Ruby, and this is why I wanted to introduce a couple concepts from the functional programming. The only 2 concepts that I try to borrow is composing and error processing. So for composing in functional programming, there exists a concept of types, and those types are something that's called algebraic data types. This could sound complex, but under the hood, that means that there are 2 operations that you actually have on types, sum and product, or in the Ruby land, we call them and or. And actually, if you see here the name of the classes, you could think it just validation. So we could say that request contract is just combination of two validations. Original parsing contract, and if this validation was successful, run the schema contract. Also, we could use the OR method. This is exactly the types sum composition, and you could say that the error that we've got from the external system could be recoverable input error, or invalid request error, or some basic error that exists in this system. And finally, we could combine them, and by combining them, we are able to actually represent any kind of complex logic with just listing the validations in particular order. But how those validations work under the hood? Actually, I use the concept called refinement types. And refinement types are just combination of type and some predicate. So the example that you could find in Wikipedia is pretty dumb. It's just integer that's greater than 5. But let's try to think about business logic. This is why I have example with cats. So imagine that you have to validate a cat. I mean that you've written an app that somehow treats cat in your system. And when you're talking about refinement types, you have to replace the actual cat with a box, with a label cat, and the rules, how you actually determine that inside is a cat. Then you're building your application with those boxes. And only at the moment when you have to produce some result for the user, you unpack it. And what happens if actually a cat in the box? Nothing fancy. You see a cat, so you just return, for our case, a parcel or user or cat. But what happens if I put my dog in this box? Don't be afraid, everything's gonna be okay. But no Armageddon happens. We just, during unpacking, we will see the context, why validation failed. So we just received another object that contained all information about why validation failed. So under the hood, in Ruby, we could represent it with a couple methods. So the first method called match, where we try to gather the context for the validation. And the second method is unpack. So what should be result of the refinement type? So for a JSON response, it could be pretty simple. So first of all, we've got the context. For example, we could get the response body, that we want to parse later, and then if the validation was successful, we just return the same object. Otherwise, we wrap an error into the another refinement type. In the advanced cases, we reuse the policy objects as well, but now they're organized in the homogeneous way. And the only difference is that we just wrap the policy errors in another refinement type. So finally, our solution looked like that. Do you see something? Yeah? No? Okay, so the base thing, the contracts were rewritten totally. So instead of using separate logic for the tagging, we just use the name of the particular refinement type for the request and for the response. And the contract just runs at first the validation over the input. If the validation was successful, we continue, we yield the block where actually HTTP transaction happens. And then the result of the block is wrapped in another refinement type. So the result of the contract match call is always a refinement type. But interesting happens under the hood. In the base contract, we use sniffer gem, which actually tracks the requests and responses. I mean the HTTP session. And we've got the same idea that we had in the first part, but instead of tagging, we have the names of the request type, response type, that we've matched, and otherwise we will see here contract failure. So exactly the same as unexpected behavior marker. So if you forgot where we have requests and responses, so they were combined by using algebraic data types. Then we apply it into our API client, so we just wrap the HTTP call in a type. And finally, we have to somehow deal with the result. And the difference here is that we have to unpack it. And the difference from the default way of using API clients, we exactly know what type of response we have. So if we were not able to recognize the request response session, we are able to see here when contract failure case. And at this point, we just notify it, and we are able to see in logs what happened. Otherwise, we exactly know how to treat those problems. If it was a policy failure, we just return validation errors. If it was a tariff contract, we exactly know that during the unpacking, it would be the the tariff. So that's pretty much it. And this solution uses only two gems, sniffer and blood contract score. The blood contract score is just the Ruby implementation of refinement types. It has no dependencies, and it introduces only and or on class, and also uses the match and unpack methods, and that's it. But what are the outcomes? So we passed through the evolution of our system. I shared with you how we learned to control input and output, how we control the state using the sagas and those distributed transactions, and finally, what is our best way to organize validations. But we have some leftovers. Dirty pipeline is not released yet because we understood that it's not right to release a gem that could not be applied just in time, because you actually have to write two interfaces, locking mechanisms and the event sourcing. So as soon as we open source those tools, you are able to install Dirty Pipeline, and you will have the simplest event sourcing in your Rails app and the distributed transactions in the way that I shared with you. And of course, I started the rewriting the blood contracts to be a simple set of small, tiny gems. So the last thing that I want to share is the list of the books and topics that inspired me. So I suggest you to read the Category Theory for Programmers if you really want to get familiar with functional programming. If you're always afraid, the Haskell, try Made the Haskell by Thoughtbot. It's greatest book to start with the Haskell. And finally, Chaos Engineering is just a topic to Google. It's an initiative from Netflix that just taught us that you shouldn't be afraid of debugging in production. Thank you. Here are some links. We'll share the library as soon as they will release. So look in our blog. You could try to use blood contract score, and I'll share this presentation in Twitter and our social networks. So thank you. Oh.